We are going to talk about the properties of limits. And first, let me explain when we use these properties. Limit x tends to a, there is a function fx, which is this limit is equal to m. Another limit is limit x tends to a, and this is what the function fx, and which is equal to n. If these two limits will exist, if these limits exist, so we can say that this properties is going to be hold. First property, we are going to see the limit x tends to a, and there is a function fx plus gx. This is what showing the addition properties. This is the addition property for the limits. So the functions which is equal to for these, the function is going to be m plus n, m plus n. Okay, let me change. Yeah, there is a mistake. Okay, let me change that. Here is a gx, not the fx, because we are taking the gx here. This is what the gx. Okay, so yeah, first property is going to be hold if the function, this function and uh, this function of fx and this function of gx, if both the limits will exist, then we can say that this property is going to be hold. So let's go for second property first. Second property, that is going to be limit x tends to a, and here is what fx minus of gx. Fx minus of gx is equal to m minus n. If the function fx or gx, if limit x tends to a, first limit, just we have seen that this is the first limit, and if limit x tends to a, fx is equal to m, and this is the second limit, limit x tends to a, gx is equal to n. If both the limits will exist, then the second and the first properties will be hold for those functions. Okay, for this third property, this is the subtraction property, this is the addition property, and we are going to see the third property. Limit x tends to a, there is a fx and gx. Fx and gx is equal to what we can say that m into n. And let's see the fourth property. Let's see the fourth property. Fourth property is going to be the division property, that is limit x tends to a, and fx divisible by gx. If the fx is divisible by gx, then we can say that this is going to be m upon n. This property will be hold true. And let's see the fifth property, that is fifth property. Fifth property is going to be, let's see, fifth property is going to be like if this is the exponential property for this limit x tends to a, and there is a f of x, there is a exponential power of x, and this is going to be m power k. This property will be hold true for these limits. If fx is having the exponential power, then the which is equal to m, but the powers will be same. And let's see the sixth property. Sixth property is going to be limit x tends to c, x tends to a, not c. Here is c, which is equal to c. Let's see what the c is. C is the constant here, constant, and we again get the same constant value because let me explain by the help of the graph. Okay, let me draw the graph. Let me draw the graph for that. If this is the x-axis and this is the constant, this is the function fx. Then this is the same function's value for all the values of x. We will get the same values, so that's why the we are getting the same limit values. And let me yes let me go for this next limit. That is limit is going to be uh, oh let me change it. Yes, limit, let me change the color so that will be easy to recognize. Limit x tends to a, limit x tends to a, and that is going to be x is equal to a. This is the property, like we are tending to a and that is going to be equal to a. This property can hold for the limit. Okay, and eighth property, let me go for the eighth property and what it is. Let's see, this is the eighth property, like polynomials, polynomial polynomial polynomials. If we have fx and we have what, gx. If we have fx or we have gx, so let's see, this is going to be if the g of a, when we put a at the place of not equal to 0. Why I'm saying like that, this is the limit x tends to a, and this is the division property, like fx upon gx. If to this is the polynomial functions, and if we put that at x is equal to a, then a, f of a upon g of a, so this will not going to be the g of a is not equal to 0. This is what all this is what the property is.